Today's lesson is over section 2.4, Writing Linear Equations. In today's lesson, we will review the methods used to write a linear equation. It depends on the given information as to what you will do. If you know the slope and y-intercept of a line, either because it's given or you know it from an equation or a graph, you can use the slope-intercept form to write an equation of a line. For instance, in these next four examples, we are asked to write the equation of a line. In problem 1, we are already given the slope and y-intercept, so we just plug into y equals mx plus b with 4 for the slope and 3 for the y-intercept, and we have the equation of our line. In example 2, we are given the slope, -2, and we're told the line passes through the point 0,5. What we have to recognize about the point 0,5 is that that point would be on the y-axis and therefore would be the y-intercept of our line, and its code for telling us b would be 5. Therefore, the equation of this line would be y equals -2x plus 5. Likewise, in problem 3, we're given the slope of 2/3 and that the line passes through 0, -1, meaning the value of b is -1, since that point will be on the y-axis, and the equation of our line would be y equals 2/3 x minus 1. Finally, our fourth example here, the slope value is 0 while the y-intercept is 2. That's going to give us y equals 0x plus 2. Of course, we know 0 times x becomes 0, so this equation simplifies to become y equals 2. In these instances where you know the slope and the y-intercept, or it's easily identified, you should use the slope-intercept form to write the equation of the line. However, if we are given the slope of a line and a point on the line, but it's not the y-intercept, that's really important. If it is not the y-intercept, or we just have 2 points on the line, can we find the equation of the line? Well, the answer is yes. There are 2 ways we can find the equation of a line. In Algebra 1, you may have used the slope-intercept form. However, in Algebra 2 and beyond, we use the point-slope form, and that's the method you'll be required to use. So it's really important you do not use the slope-intercept form, but instead use the point-slope form. And that's what you're going to find on our next slide. The point-slope equation is y minus y sub 1 equals m times the quantity x minus x sub 1, where m will represent the slope of the line and x sub 1, y sub 1 are the coordinates of a point on the line. So we have some problems. So the first one says, use the point-slope form to write the equation of the line. Now, remember, you're going to have to know this equation for your quiz, which will be on the block days, Thursday and Friday. So you're going to have a short quiz over writing equations of lines, and you'll need to know that point-slope equation. Some students like to write it at the top of their page, and then they just use it each time. I find that it can be helpful to write it each time so that you learn it, but whichever works for you is fine for me. And so here, when we plug in, the coordinates of our point are going to be what we plug in for x sub 1 and y sub 1, and then, of course, m is -3. So given our form, I'm going to have y minus 3 equals, and that's my y coordinate, my slope value, -3, times the quantity x minus x sub 1, which is 2. I can't leave my answer in this form. We need to simplify by distributing on the right side and then by rewriting our final answer in slope-intercept form. So I distributed the -3, which gives me -3x plus 6. Then I'm going to add 3 to both sides, which adding +3 here is not a big deal. And we get y equals -3x plus 9. How about the next one? This time we know our slope value is 1/2 and our line passes through 2, 5. So I'm going to say y minus the y-coordinate of 5 equals the slope value of 1/2 times the quantity x minus the given x-coordinate, which is 2. So I have y minus 5 equals 1/2 x minus 1, since 1/2 times -2 is -1. Of course, I'm going to add 5 to both sides, and when I do that, I'm going to get y equals 1/2 x, and then that would be plus 4. If it helps, it might be useful to show this step so you don't make a careless mistake. That is also the case up here in the previous example. We could have shown add 3 to both sides. I just want you to avoid careless mistakes. Now, the next two examples, they give us slightly different information. They say the line passes through -2, 3 and -1, 1, which is 2 points. Unfortunately, we don't know the slope. So the first thing we're going to need to do is find the slope of the line that passes through our 2 points. And it doesn't really matter the order I subtract. I usually start with the second point. So I went 1 minus 3. That's the change in the y-coordinates over, it would be -1 minus a -2. And that becomes -2 over, that'd be +1, which of course is -2. Oops. There we go. So now I just plug in. Now, it doesn't matter which point I use. I can use either point. I'll pick this point just because the numbers are smaller. So I'm going to have y minus the y-coordinate of 1 equals the slope -2 times x. Now, this is really minus a -1. I usually go straight to writing x plus 1 because I know if I'm putting in minus a -1, since that's my coordinate here, that it's going to become plus. So if you're comfortable going right here, that's absolutely fine. Of course, I'm going to distribute. So the right side becomes -2x minus 2. Add 1 to both sides. And when I do that, I get -2x minus 1. Final example. You try. The line passes through the points -1, 4 and -3, -5. So go ahead and find your slope value. See if you can do that. I'll give you a second to try to find that. And then I'm going to do it. So it looks like I'm getting -9 over -2, which a negative over a negative reduces to a positive 9/2. Pick a point. I don't care. I'm going to pick the first one. So I'm going to plug in here. So I'm going to have y minus 4 equals 9/2 times the quantity x plus 1 minus a -1. So I have y minus 4 equals 9/2 x plus 9/2. Of course, I'm going to need to add 4 to both sides. And I'm showing this simply because we have a fraction. You might want to go out in the margin if you're not as comfortable with your fractions. you're adding 4 over 1. Remember, you have to get a common denominator. That would be 2. If I multiply the denominator by 2, I've got to multiply the numerator by 2. This is a 2. And so it looks like we're going to get y equals 9 halves x plus 17 halves. Good. Hopefully you got that answer and you're good to go. Homework. You are doing what you see down here. Should be listed on my Canvas page as well, but page 87, 8 to 22 even. Then tomorrow in class, we will add information about parallel and perpendicular lines to our lesson to see how that changes things up and go from there. Hope you had a great day. Thanks.